In this lesson, we're going to consider problems where we are given an initial value and a derivative, and we're trying to find the original function. All right, as we read through this one, we've got that lowercase and capital case, F thing going on. It's helpful to know that oftentimes capital F is the antiderivative, but it always is going to tell you that clearly. And if we look right here, we can see that we were given that lowercase f equals f prime. So let's just right away, where we see our equations down here, say, oh, lowercase, lowercase. So lowercase f is capital F prime. And now we probably feel more comfortable when we're asked to find the function f, because here I have f prime. All right, so let's go ahead and find our antiderivative to find that function for capital F. And we're going to have x squared plus c. The difference here is we're not done because we were given an initial condition. Right here is our initial condition, and our initial condition allows us to solve for c. All right, so let's do that. When I have the initial condition 0, 5, that means that the point 0, 5 is on this graph. So we can plug 5 in for y, f being our y in this case, and 0 in for x. And we see that c is 5. And so we just rewrite our function, f equals x squared plus 5, and we're done with that one. All right, so let's do the same process again with this next problem. Now in this next problem, our first step, we're actually just given f prime and asked to find f. Over here's our initial condition. But before I jump in and do the antiderivative, this is one of those problems where it's going to help me to rewrite it. So I'm going to rewrite it, and notice that I'm still labeling it as f prime, so it's clear I have not found the antiderivative yet. All I am doing is rewriting the problem so it's going to be easier when I want to find the antiderivative. So f of x equals x squared. And let's see, I want to raise this to a negative 3, which means I'm going to divide this number by negative 3, and it's going to be plus. Ones like this, I always like to check. Let's go backwards. Derivative of x to the negative 3 would be negative 3x to the negative 4. So that looks good. And I need a plus c. Now I use my initial condition, and I'm going to plug it in, 3 in for the y and 1 in for the x's. And I know 1 to any power is 1, so I've got 3 equals 2 plus c, which means that c is 1. Last step, rewrite that function with that value for c. X squared plus x to the negative 3 plus 1. All right, this next problem is very similar, so I would encourage you to pause and try it on your own before you listen to the explanation. All right, welcome back. When I do this problem, it is helpful to think of this as being 2 times 1 over x, because I know that antiderivative for 1 over x. So f of x then would equal 2 times the natural log of the absolute value of x plus c. Good thing we have the absolute value, because in this case we're told x is less than 0. All right, here's our initial condition. Let's plug it in. 7 equals 2 times the natural log of the absolute value of negative 1 plus c. Natural log of 1 is 0, so I'm going to have 7 equals 0 plus c, which means c equals 7. So we've got f of x equals 2 natural log, absolute value of x, plus 7. All right, in this next problem, we're given the second derivative of x. We're supposed to find f of x, and we're given two conditions. We're told f prime 1 is 4 and f of 1 equals 3. This is going to be a two-step problem. First, we're going to find the first derivative by finding our first antiderivative. So antiderivative of 6x is 3x squared plus 6x plus c. And then I'm going to use this first condition right here to find that c. So I've got 4 equals 3 times 1 squared plus 6 times 1 plus c. So 4 equals 3 plus 6 plus c. Looks like 4 minus 9, or negative 5, equals c. So I rewrite my function, f prime of x equals 3x squared plus 6x minus 5. All right, so I've done the first level. Now I do another antiderivative to get to f of x. Antiderivative of 3x squared is going to be x cubed plus, I recognize this one, it'll be 3x squared minus 5x plus c, it is not the same c as that one, so maybe we'll just put c sub 1 so that we see that it's a completely different c. Now I use my other initial value right here to figure out that one. So I'm going to be, let's see, my y is going to be 3, and my x is 1 again. So I've got 1 cubed plus 3 times 1 squared minus 5 times 1 plus c1. So 3 equals 1 plus 3 minus 5 plus c sub 1. So let's see, I've got 4 minus 5 is negative 1. So 3 equals negative 1 plus c sub 1, or c sub 1 is going to be 4. So our last step, rewrite this, f of x equals x cubed plus 3x squared minus 5x plus 4. All right, let's move on to our next problem. This is really going to be the same thing. So again, this is a great one to pause on and try on your own before you listen to the explanation. All right, welcome back. Remember, just like before, we're going to find f prime of x. Antiderivative of 3 to e to the x is 3e to the x minus 5 cosine x plus c. All right, we're going to use our first initial condition here. 2 equals 3e to the 0 minus 5 cosine 0 plus c. So 2 equals, let's see, e to the 0 is 1, so that's going to be 3. Cosine of 0 is 1, so it's going to be minus 5 plus c. And see, 2 equals negative 2 plus c. Looks like c is going to be 4. So we'll rewrite this one. And we're ready to now do f of x. So f of x is going to be the antiderivative of this one. Of course, e to the x is always easy to work with. Antiderivative of negative 5 cosine x is going to be minus 5 sine x plus 4x plus c, different c, so I'll do c sub 1. And then we're going to use this other initial condition. So we'll come down here, and we have, let's see, my y is 1 equals 3e to the 0 minus 5 sine 0 plus 4 times 0 plus c1. This is nice because e to the 0 is 1, but the rest of these are 0. Sine of 0 is 0, and this next thing is 0. And so c sub 1 is going to simply be negative 2. So we've got f of x equals 3e to the x minus 5 sine x plus 4x minus 2. All right, we've got one last problem to go through. And this one's a little different than the others. Oops, sorry about that. We are asked to find the number or numbers b such that the average value of f of x equals 2 plus 6x on the interval 0 to b is equal to 8. Now this looks so different, it might get your blood pressure up a bit. But the first thing you should grab onto is average value and say, oh, I know the formula for average value. Let's see, average value is when I do 1 over b minus a, where that's my interval. Oh, here's my interval. So my interval doesn't go from a to b, it goes from 0 to b. So let's just fix that up. So let's start that again. So that's going to be 1 over b minus 0. Now I know my integral goes from 0 to b, and it's the average value of that function. So 2 plus 6x dx, and I'm told that the average value is equal to 8. All right, so we've done the hardest part, which is just setting up what equation we're working with. The next is just working through the math and the calculus. So here we've got 1 over b. Over here we can find that antiderivative. So we've got 2x plus 3x squared. And we evaluate this thing from 0 to b, and it's going to equal 8. All right? Now, even though these are letters and not numbers, the process is the same. First, I plug in b. So I've got 2b plus 3b squared minus, and I plug in 0. You'll notice that those are both going to be 0, so that really doesn't change anything. So now I've got 1 over b times 2b plus 3b squared equals 8. Well, I can multiply out 1 over b. 1 over b times 2b is 2. And 1 over b times 3b squared is 3b, because one of the b's cancels. And that's equal to 8. And now I've got a pretty simple equation. To finish up, let's come up here. So 3b equals 6 and b equals 2, and we have answered this question. That is the number b. That is going to allow for an average value of 8. All right, so we're on to homework. This is homework number 4.